How much? 2259. All right, 2259 joules per gram. So 2259 minus 900. I'm sorry. Times 900. So that's going to be 2,033,100 joules. That's 2 million joules of energy that it would take to cool steam from 100 degrees centigrade to a liquid at 100 degrees centigrade. So that's a liquid. This is a gas. So that right there, you would have to cool it down that much. That's what condensing means. And then you're going to have to condense from here to here. So we'll save this number. Q equals the mass, which is again 900 grams, times 4.184. Now, the final temperature is what? 30? Minus the initial temperature at 100. Okay. So that means in step 2, we're going to have to lose negative 263,000 joules. So we're putting this in the refrigerator. Negative 2 million joules is coming off of it, and now we're at liquid water. And then negative 263,000 joules is coming off of it, and now we are at 30 degrees centigrade. So what is the total amount? 2063,592 plus 2,033,100. So that means 2296692 joules of energy total would have to be removed from the system.
And you'd want that quoted as a positive because it's asking how much is removed.
It wouldn't matter. Yeah, since it has a word, how much is removed, positive would be the right answer. So number 57 is the last one. How am I doing so far? Good? Bad? All right. 57. Well, suppose 1 mole of water evaporates in 1 day. How many water molecules on average leave the liquid each second? Okay. So if 1 mole evaporates per day, I want to know how many moles would evaporate per second. Now, how many seconds are in a day? Well, there's 60 seconds in a minute, right? So 60 times 60 is how many seconds are in an hour, times 24. So that means 86,400 seconds is the same thing as 1 day. Are we happy with that? Okay. So 86,400 seconds equals 1 mole of water evaporated. X moles of water. Now, how many moles would that be per second? then. Would it be 1 divided by that? Okay, 1 divided by 864.00. All right, so that's going to be 1.157 times 10 to the minus 5 moles evaporate per second. Now the problem wants to know what? How many molecules evaporate per second? Well, in 1 mole, there's an Avogadro's number. So that means 6.9 times 10 to the 18th molecules per second. Will that work for you? So that's a bunch of little bitty molecules that's going to be hitting your skin per second, if that's the evaporation rate, right? Which naturally living in Florida, we know that's pretty accurate. Because how long does it take you to get wet when you walk outside and it's 98 degrees with all this humidity, right? Not very long. It's quite sticky out there, especially right after a rain when stuff is evaporating very readily. All right, are we good with 13? You happy with 13? Should we do 14? All right, well, 14 talks about the concentration issues. All right. And we'll talk about that. Now, we've already talked about one concentration issue yesterday, and that was something about alcohols. And we know that how alcohols are measured, or for any hydrogen bonding liquid, I suppose, with the exception of water, even though water does have a concentration, is this. There's something out there that's called a percent VV, and that stands for the volume of liquid in question, which most of the time is something like an alcohol, divided by the total volume of the solute, total volume of the solution, times 100. That's what a percent VV is. So that's one way to come up with concentration. Okay? Now concentration, you know, you can talk about something being concentrated or weak or dilute. And those are just terms that do not put math with it. I mean, naturally you guys know what I'm talking about, right? Like if someone makes sweet tea and they just go overboard and you taste the sweet tea, you'd be like, God, that's sweet. I mean, like an inordinate amount of sweet. Or if someone does just a little bit of sugar. So that's a very concentrated versus very dilute solution. Well, these are ways to just put numbers with them so you can quantify it and figure out exactly how much you got. Now, that's one thing we talked about. The second thing we talked about is proof. And what a proof is a percent VV multiplied by 2. That's a proof. Now, the third thing, and the most common probably, is something that's called a percent WW. Now, that stands for percent weight. Because, you know, chemists, we have balances all over the place, so it's a very simple thing to do. There's not much error when you talk about weighing things. I mean, you know, certainly there's error in everything you do. So what this stands for is the mass of the solute divided by the mass of the